I was asked by a television producer to please make a permanent record while I'm still alive of what some of the design challenges were for the Kettlewell frictionless mouthpiece slider. The invention is designed to make movement to new note hole positions friction-free without the use of saliva. But it also, with a one hole, allows a very relaxed embouchure. I don't have to do that. And there isn't saliva dribbling all over the place. You don't have to use saliva that drives to lubricate. So let's go back in time and to my thoughts early on. And it started with a guy who had blisters on his lips, and I said, from playing, and I said, well, if you could find something that you could put your lips on and make that run go left and right on the harmonica, you lick that problem. I started thinking about it. And I thought, there's got to be a way to move left and right that's airtight. These are original designs from that time period. Early on, the concept was to make something which would bolt onto a harmonica like a mouthpiece, but it wouldn't really be a mouthpiece. It would be a receiver for what I called early on the slider. And the slider would be something that your lips would sit on, and it would do the sliding. So that's why it's called a slider. Okay. So the initial thinking was, okay, you change the mouthpiece out for a lower. That's what that was going to be called. The lower part was called the lower, and the upper part was called an upper or a slider. And then one day, somebody tried doing that, and I told them the way we were going to do it in Holland. And the Kellery Instrument Company, I like the people very much, beautiful craftsmen, and they made one, and I said, it won't work, and why? And I said, because it's flat brass on the bottom, that's the lower, and it won't be airtight. I knew the tolerances had to be very, very accurate. And so, but let's back up and talk about the physics a little bit, the scientific part of it. Why was it difficult? It was difficult because two things, which are physical properties, had to exist at the same time and work that are opposed, typically. It had to be airtight. It had to be absolutely airtight. The part that your lip would go on. And its interface with the lower had to be totally airtight. But it had to be friction-free. It had to be able to move with no friction, but be airtight. But airtight things like jars, they're tight. And fittings, mechanical fittings, they're tight. Tightness is typically used as the methodology to accomplish airtightness. So tight, airtight, that word itself insinuates tight to make it airtight. Okay, so in everybody's thinking it was pressure, down pressure, tightness, like the screws on a harmonica. They're airtight because they screw down and the parts are compressed, and that makes the airtightness. Okay, so that's got to happen. It's got to be airtight. totally airtight. But it has to be able to move left and right easily. This was a conundrum. An early drawing of a lower. And then one day, I said to myself, well, how come you couldn't just take, and this is a copy of what it was, a piece of metal and cut a hole in it and just plop it on there. And if it fit pretty good, couldn't it go back and forth? And couldn't it, a piece of paper moves. It moves. Could it be airtight? Not a piece of paper. So I thought, well, maybe. It doesn't have to have a lower. Then a guy came along in California who had done much of the build-out work on the Pissardo harps that are patented. And he came up with this. This was the first working slider in history. Brian DeSalle. It had 4 ball bearings here and here and here and here on springs. And a piece of Delrin up there glued on. And it would slide back and forth on a Pissardo. It worked. But my impression when I saw the drawings in California, I said, it's brilliant and it's genius, but it's over-designed. He goes, well, what do you mean? I said, there's a simpler solution. No, there's not. I said, okay. It had something called stiction, S-T-I-C-T-I-O-N, which meant that it had a little bit of drag left and right. It wasn't friction-free. I was at my wit's end. Nobody could lick it. Nobody could come up with the right answer. And I finally thought, I'm going to do it myself. I've been waiting a year to have somebody make it. And I thought, I'm going to go get, I had an award in the basement that I won for some kind of television thing. I don't know, like this, you know? And I cut a hunk out of it. It was white like this. And I thought, I can make this fit. And I covered the harp with clear packing tape and wrapped tape around it, took the slide out, and I took this hunk and I ground out the bottom with a Dremel into a shape kind of like that on the bottom. And then on the top, I used a bench grinder, and then I sanded it. And I had the first airtight, friction-free slider. And I called it Cool Ice because they're like ice. They don't have any. And what is this? This is lucite, which is a high-quality aged acrylic material, indestructible, no moving parts. Accurate within 1 or 2 10,000ths of an inch. Okay. And then it started getting to fit to all kinds of harps. And I learned that I could make the top shape trapezoidal or rounded, but depending on what I wanted, you know, so in other words, the outer shape could be anything. It wasn't, you know, so you could... can do anything a normal harmonica can do, but because it's a freestanding unit, and by that I mean it didn't require a lower You could play it like that or play it as a normal harp, and there was no modification needed. But so all those problems were taken care of and licked in time. But the big physical challenge was airtight, but friction-free. That was the challenge. I learned over time that this edge here on the inside and there had to be ground a little bit so that you didn't hear clickety-clack. And the same with the hole, around the hole, it had to be smooth so that it didn't go clickety-clack and was silent on the unit. And that the top probably needed to be smooth too for your lips. That was the history of the answer to the physical challenges of the slider. Andrea Antonello Nacci, Italian composer, has said that in his opinion the slider will be ubiquitous or used by most players in 30 years. Its popularity has grown a lot in the last year. I don't know how far it's going to go. I think it's got different characteristics than a normal harmonica, but I only play with the slider, and mainly because I like how it keeps my harps clean. I can play a wood-combed harp and it doesn't get dirty. I also like the relaxation of my lip. I feel it's more modern. That's the story.